Guys, so this is question number 3. It's a question on frictions. It says a bend bell is used to control the speed of a flywheel as shown, knowing that the coefficient of friction between the bell and the flywheel is 0.25 and the flywheel is rotating clockwise at a constant speed. And what it asks us to do is that first we need to draw a free body diagram, and then we determine the magnitude of the couple being applied to the flywheel. So which means that we need to find out what's the m, which is the moment, and then we need to determine the horizontal and vertical components of the reaction at P so which means that we need to find cy and cx. Okay, so I already worked out the first form for you guys, so you guys can see it clearly. So I save some times. So I keep the video as short as possible so that you guys don't have to watch a long ass video. All right, so here's the feedback that I want to show, and then uh, the beta, which is the contact area. So beta is from this point, right? So beta is this entire contact area right here. All right, because as you can see, same thing right here. All right, and then so we know that entire circle is a 360 degree, right? And this is like 3/4 of a circle, so which will be 270. Okay, and then we just basically convert that to radians, so which I got 3 pi over 2. Okay, and then next thing what I have to do is that I have to find out what T1 and T2 is. Okay, so part B. Okay, excuse me. We know that T2 will be equal to T1 e raised to the mu beta, right? Which that will be equal to T1 e to the mu, which is a 0.25, beta, which is a 3 pi over 2. So T2 will be equal to T1, which will be 3.2481. T1, right? Okay, so we can't find T2 right now because we don't know what T1 is. So what we can do at this point is that we can consider this free body diagram right here, and then to see if we can find out what T1 is, or let's find out what T2 is. So let's take a moment about point C. Consider it counterclockwise as positive. So T1 is going counterclockwise. Distance between it is 80 millimeter, okay, which will be 0.08. All right, and then minus, yeah, no, hold on. Yeah, it would be plus T2, same distance between them, 0.08, and then minus 100, because this 100 is going clockwise, right? Minus 100, distance between them is 320 millimeters. Well, let's convert that to meters, so 0.32, okay, equal to 0. All right. Next, what we can do is that we can get this 0.08 out. So T1 plus T2 will be equal to, so 100 multiplied by 0.32 is equals 32. And then divide both sides by 0.08. So we get T1 plus T2 is equal to 400. Okay. All right. So next thing what we can do is that we know that T2 is equal to 3.2481, right? T2 is equal to 3.2481 T1. So we can sub that in. So T1 plus 3.2481 T1 is equal to 400, right? And then simply just solve for T1. Okay? So we get T1. So this will be 4. Yeah, so simply just solve for T1. Okay, so T1 will be equal to 400 divided by this T1 plus 3.2481 T1 will be 4.281, right? And then T1 will be equal to 94.1597 newtons. Okay. All right, and then we can find out what T2 is. So T2 is equal to 3.2481 multiplied by 94.1597. So T2 will be equal to 305.84. newtons, right? Okay, and then let's find out what the moments is, okay? So moment, so right here, we need to find out what this couple moment right here is, okay? So let's take a moment about E, consider counterclockwise as positive. Okay, so we know what T1 and T2 is right here. T1 is equal to 94 point, let's just call it 94.16. T2 right here is equal to 305.84, okay? So T1, that's going to in the clockwise direction. So it'll be negative 94.16. And then the distance will be this radius, which will be 0.15 plus T2 is in the counterclockwise direction. 5.84, 0.15, and then moment that is going in the counterclockwise direction too. So minus m e equals 0. And then just simply solve for me. So me, if you just solve for this equation, you're going to get me is equal to 31.75 Newton meter. Okay, so we find out the first part. And then what we have to do right here is that we need to find out what the Cx and Cy is. Take a summation of the force in the x direction and the y direction for this feedback diagram right here. So for this diagram right here, so T1 is going to be negative T1 minus P minus Cx, right? Equal to 0. So we get Cx is equal to negative T1, which is 94.16. Hold on. Yeah, negative 94.16 minus 100. So Cx will be negative 194.16 newtons. Okay, so that's for the Cx. And then for the Cy, so summation of force in the y direction. Cy, we have T2, which is going downwards, so negative T2 plus Cy 0. So Cy is equal to T2, which will be equal to 305.84 newtons. Right? Okay. So this is it. This question.